In this video, we're going to start laying the groundwork for multiplying and dividing rational expressions. So remember, a rational expression is just a fraction whose numerator and denominator are both polynomials. So in order to effectively multiply and divide rational expressions, the first thing I'm going to show you is the process we use for simplifying a single rational expression. And the process we use to do this is going to be exactly the same as when we simplify numeric fractions. So let's take, for example, 24 over 60. We could write both the numerator and denominator in their most basic forms, the prime factorizations. What we would do then is just cancel out any common factors. So obviously with numeric fractions this seems to be pretty tedious because we've already been doing it for years and we're usually pretty good at seeing the greatest common factor of two numbers and just dividing it out. In fact, you probably already know this will simplify down to 2/5. But for the sake of seeing the process, let's work it out. So I'm going to take and find the prime factorization of the numerator and the denominator. And 24 breaks down to 2 times 2 times 2 times 3. And 60 breaks down to 2 times 2 times 3 times 5. So the first thing I did is I completely factored the number. Okay? So secondly now we're going to cancel any common factors. So they share a 2 right there, another set of 2's right there, and 3's right there. So what's left over? Well, just a 2 in the numerator and just a 5 in the denominator. So I'm going to say the simplified form of 24/60ths will be 2/5. Okay? And which you probably knew as soon as you saw 24/60ths on the video screen. Okay? So what will this look like for a rational expression? Well, let's look at a few quick examples. Okay? So I've got 6x minus 30 for the first one, and that's my numerator. And my denominator will be x squared minus 6x plus 5. So the most important thing to remember and to make sure we do every time is that you cannot cancel anything until you've factored it. Factor first, then cancel common factors. The numerator here, it looks like I can pull out a greatest common factor of 6, and I'm left with x minus 5. In the denominator, it looks like I have a quadratic trinomial. So what two numbers multiply to make 5 that add to make 6? Well, it looks like x minus 1 and x minus 5. So do they share a common factor? Well, yes, they do. This x minus 5, right? So when I cancel that x minus 5 out, what do I have left over? Well, 6 over x minus 1. But there's one quick conversation we need to have about all this, and it talks about domain. So remember when you're talking about rational functions or rational expressions, you cannot have a 0 in the denominator. So any value of x that will cause this denominator to be 0, we have to take out of the domain, right? Or we say that it's excluded from the domain, because that would be an x value that when we plug it in would cause the expression to be undefined, division by 0. Well, looking at this initial rational expression, when I factor this out, I have x minus 1 and x minus 5 for the denominators, so I know that x cannot be 1 or 5. Well, when I simplify this in wholes, we have 6 over x minus 1. Well, I kind of see that x can't be 1. It was kind of understood, and I can see it already. But the problem I have is, didn't I cancel out the x minus 5's? So the thing I need to keep along with my answer is that x cannot be equal to 5. Okay? So what happened is we canceled out this x minus 5, but since we're simplifying this original rational expression, yes, it simplifies down to 6 over x minus 1, but we have to keep the stipulation that x couldn't be 5 originally, so it can't be 5 here either. Okay, that's the first example. So let's look at another one. So I have x squared plus 3x minus 10 in the numerator, and the denominator will be x squared plus 7x plus 10. Well, keep in mind again, I cannot cancel until I factor. So it's no good to cancel the 10s or cancel the x squareds. You can't be doing that business. Okay? So we're going to factor first. So this looks like it's going to factor as x plus 5, x minus 2 on top. And the bottom looks like it's going to factor as x plus 5, x plus 2 on bottom. And we see again that they do have a common factor. X plus 5s will cancel out nicely. And what I'm left with is x minus 2 over x plus 2. But let's consider our domain restriction here. When I factored the denominator, I saw that x could not be negative 5 or negative 2. After the simplification process, I still see that x can't be negative 2. But the one that I've lost is x cannot be negative 5 because that's what canceled out. And again, this is a simplified version of this initial rational expression, so I have to keep the integrity of the expression and say, well, x can't be negative 5 and negative 2 here, so it also can't be negative 2 or negative 5 here. Okay? Here is one common mistake that students make. They either see the 2's here or the x's here, and they start to just hack off pieces of the expressions. Well, you can't do that. Here's what happens when you do that. It's just like saying, look, I have 32 over 52, and you say, hey, they both end in 2. So let's go ahead and cancel those 2 out, and we have 3/5. Okay, you can't do that, right? You know you can't do that. That's crazy talk when you look at it that way. So don't cancel the 2's right here or the x's here. Okay, the x minus 2 and the x plus 2 are binomials. They stick together. Let's do one more example. So I'm going to have 3 minus x over x squared minus 5x plus 6. This is going to be a really important example because I'm going to show you a technique that you're going to use later on. So 3 minus x, you can't factor that. He's already, well, a binomial, and there's no GCF or anything like that. So the bottom here looks like x minus 2 and x minus 3. And you look at this and you say, well, it doesn't look like anything will cancel out automatically, but we're going to do a little something here because 3 minus x and x minus 3, they look pretty close to being the same thing. They're both subtraction. It's just that my terms are flipped. 3 minus x, x minus 3. So here's a little thing I'm going to do. In the numerator, I'm going to factor out a negative 1. And when I do that, I'll have negative 3 plus x. And now let's rewrite this. So negative 1, but let's switch the order. So x minus 3 over x minus 2, x minus 3. What do we notice here? Well, we notice that now the x minus 3's are the same, and we can cancel them. So what am I left with? Negative 1 over x minus 2. Okay, but again, for our domain, we need to consider what were the restrictions previously. Well, I knew that x could not be 2 or 3. Well, it's obvious that x can't be 2 here, but we canceled out the x minus 3, so we need to keep the stipulation here that x cannot equal 3 either. Okay, so this is what this simplified version will look like. And once again, let's kind of see what we did. We noticed that the 3 minus x and the x minus 3 were the same, except kind of they're backwards, right, from each other, both subtraction, but here the 3 came first and here the x came first. So you can get into the habit, if you like, just of canceling those out and leaving a negative 1. And you'll see that that's exactly what happened here in this case. So now we know how to simplify a rational expression by factoring. So in the next video, we're going to look at multiplying some basic rational expressions.